this lesson I'll complete the subject of continuity. Example, discuss the continuity of the following. Number 1, f of x equal to 3x power 2 minus x minus 2 over x minus 1 when x not equal to 1, 1 when x equal to 1, at x equal 1. First, I find f of 1. f of 1 when x equal to 1 is 1. Then I'll find the limit when x approach 1. When x approach 1, I'll use this segment. 3x power 2, x approach 1, it means x not equal to 1, minus x minus 2 over x minus 1. If we substitute directly, then the denominator will be 0. Therefore, I'll try to analyze the numerator by experiment. 3x by x minus 1 plus 2. This one, 3x power 2, 2x minus 3x minus x minus 2 over x minus 1. Reduce x minus 1 with x minus 1. Substitute every x with 1. 3 times 1, 3 plus 2, 5. Then this function is discontinuous at x equal 1 because the value of the function not equal to the limit of the function when x approach to 1. Number 2, f of x equal square root x minus 2 when x greater than or equal to 2 minus x when x less than 2. f of 2 equal to, I'll substitute in the first segment because the equal is here. Square root 2 minus 2 equal 0. Limit x approach 2 from left, I'll take it from left and from right because 2 appear in 2 interval. Therefore, from left when x less than 2, I substitute here in this segment 2 minus 2 equals 0. Sure, from right it is also 0 because I'll substitute here x minus 2 equal to square root 2 minus 2 equal to 0. Since the value of the function equal to the limit of the function and both equal 0, then this function is continuous at x equal 2. Which is continuous? Which of the following function is continuous at x equal 1? Let us check one by one. Limit or f of 1 here, when x equal 1, it is negative 3. And the limit when x approach to 1, for this function, absolute value x minus 1 over x minus 1, if I substitute directly, it is 0 over 0. But if I want to simplify this function, I'll remove the absolute value by using its definition. It is equal to x minus 1 when x greater than or equal 1, negative x plus 1 when x less than 1. Then I'll take it from left and from right. And I'll see if it is equal to negative 3 or not. When x equal to 1 from right, x minus 1 absolute value equal to x minus 1 over x minus 1, reduce x minus 1 with x minus 1, the answer is 1. Since negative 3 not equal to 1, then this function is discontinuous. Let us see number B. f of 1 equal to 2 over 3. The limit when x approach to 1 to x power 2 minus 1 over x power 3 minus 1. substitute directly, the answer is 0 over 0. Then open the numerator difference of 2 square, x minus 1, x plus 1. Analyze the denominator difference of 2 cube, x minus 1, x power 2, reverse sign, x plus 1. X minus 1 with x minus 1, substitute every x with 1, 2 over 1 plus 1, 2 over 1 plus 1 plus 1, 2 over 3. Since the value of the function equal to the limit of the function, then this function is continuous at x equal 1. Let us see number C. F of 1 equals 3. The limit when x approach 1 for this function, it is equal to, substitute directly, it is 0 over 0. Analyze the denominator by difference of 2 square. Square root x, positive 1, negative 1. Square root negative x minus 1 with square root x minus 1. Substitute every x with 1. Square root 1 plus 1, it is 1/2. And since the limit not equal to the value, it is discontinuous. The last function, f of 1 equal to 7, and limit when x approach 1, substitute in this function x minus 1 over 2 minus square root 4x. If you substitute directly 1, then 2 minus 4 times square root 4 times 1, square root 4. Square root 4, 2. 2 minus 2, 0. Then I'll need to simplify this function. Limit x approach 1, x minus 1, 2 minus square root 4 is 2, 2 square root x. Factorize the denominator by 2, then 1 by negative 2. The answer will be square root x minus 1. Square root x minus 1. Now, analyze the numerator difference of 2 square. Then it will be limit x approach 1, square root x minus 1, square root x plus 1 over negative 2, square root x minus 1. Reduce square root x minus 1 with square root x minus 1. Substitute every x with 1. Then 1 plus 1, 2 over negative 2. The answer is negative 1. This function is discontinuous. Then the right answer is B. Question number 4. Over which interval the function f of x equals square root x plus 1 over x minus 1 has a point of discontinuity? This function has point of discontinuity when the term under the root is negative. Therefore, x plus 1 over x minus 1 less than 0, or less than 0. Yes. This term is less than 0 when the numerator is positive and denominator is negative, or the reverse, the numerator is negative and the denominator is positive. Therefore, x plus 1 greater than 0 and x minus 1 less than or equal 0 also, because the denominator should not be 0, then 0 is a discontinuous point for this function. Let me solve this case: x greater than -1 and x less than or equal 1. X greater than -1, it means that this is -1, this is 1. It means -1 to infinity. X less than or equal 1, it means -infinity to 1. The intersection of these 2 points of these 2 intervals is -1 to 1. -1 to 1. -1, sorry. 1 is within the interval. -1, it is not in the interval because it's not belong to this interval. The second case, when x plus 1 less than 0 and x minus 1 greater than or equal 0. In this case also, this term will be less than 0. Let me solve these two inequalities: x less than -1 and x greater than or equal 1. The intersection of these two intervals, x less than -1, this is -1, this is less than -1, greater than 1, this is greater than 1, the intersection is phi. Therefore, the interval of discontinuity point for this function is -1 to 1, open from -1, closed from 1. Number 5, it is similar to number 4. The function f of x, square root x plus 1 over x, is discontinuous over which of these following intervals? Also, x plus 1 over x should be less than 0. Therefore, either x plus 1 greater than 0 and x less than or equal 0. In this case, x greater than -1 and x less than or equal 0. The intersection, x greater than -1, it means -1 to positive infinity. X less than or equal 0, it means -infinity to 0. The intersection is -1 to 0, close from 0, open from -1. This is from the first case. From the second case, x plus 1 less than 0 and x greater than or equal 0. It means x less than -1 and x greater than or equal 0. X less than -1, this is -1. Less than -1, it is -infinity to -1. X greater than 0, it means 0 to positive infinity. The intersection is phi. The right choice is B. Question number 6. The function f of x equal 1 over square root x minus 4 is continuous over which of the following function? To find the interval of the continuity of this function, find the domain of the function. The domain is x -4 should be greater than 0, not greater than or equal. X minus 4 greater than 0, it means x greater than 4. X greater than 4, it is 4 to positive infinity open interval. The right choice is B. Point of discontinuity of the function f of x equal 1 over sine pi x over 2. Also, find the domain of this function. The domain is all real number except point make the denominator 0. The point make the denominator 0, I can find it as set pi x over 2 equal to n pi, since n pi is the x-intercept point of the sine function. Therefore, find the value of x from this equation, reduce pi with pi, then x equal to n. Choice B. Number 8, f of x equal x power 2 minus 5x plus 6 when x less than 3, x minus 3, 2x minus 4 when x greater than 3. Discuss the removability of f of x, of the removability continuous of f of x at x equal 3. Now, as you see, the function is not defined at 3, but we can redefine this function to be continuous if the limit of this function exists. So let us find the limit when x approach 3 from left. Use this segment, x power 2 minus 5x plus 6 over x minus 3. If you substitute directly, then you will get an undefined term. But let us analyze the numerator by experiment. X positive, negative, so it is negative 2, 3 over x minus 3. X minus 3 with x minus 3, substitute every x with 3, 3 minus 1, 3 minus 2 equal 1. The limit when x approaches 3 from right, I'll use this segment, 2x minus 4 equal to 2 times 3 minus 4 equal to 6 minus 4 equal to 2. Since the function has no limit when x approaches to 3, then this function has no removable discontinuity at x equal 3. Question number 9. Find a so that the function f of x equal 3a plus xx greater than negative 1 x power 2 plus 4ax when x less than negative 1 have no point of discontinuity. Since the function has no point of discontinuity, the limit of this function when x approaches to negative 1 should be exist. Therefore, the limit when x approaches to negative 1 from left, use this segment, x power 2 plus 4ax equal to, substitute every x with negative 1 square minus 4a equal to 1 minus 4a. And the limit when x approaches to negative 1 from right, use this segment, 3a plus x, substitute every x with negative 1. The answer is 3a minus 1. Since the limit should be exist, therefore 1 minus 4a should be equal to the 3a minus 1. Then set the term with a in one side, 3a plus 4a equal to 1 plus 1, 7a equal to 2a equal to 2 over 7. Question number 10. Find the value of a and b so that the function defined by this image have no point of discontinuity. The function, since it have no point of discontinuity, then the limit of this function when x approaches to 2 should be exist, and the limit of this function when x approaches to 4 also should be exist. First, I find the limit when x approach to 2. From left, when x less than 2, the function is 2x minus 1. Substitute every x with 2. 2 times 2, 4 minus 1. 2 times 2 minus 1 equal to 3. And the limit when x approach to 2 from right, use this segment ax plus b, substitute every x with 2, then the answer is 2a plus b. And 2a plus b should be equal to 3 so that the limit to be exists. And now I'll find the limit when x approach to 4 from left. I'll use this segment ax plus b, substitute every x with 4. The answer is 4a plus b. And the limit when x approach to 4 from right, when x greater than 4, the function is 2x plus 3. Substitute every x with 4, then 2 times 4 plus 3 equal to 11. And 4a plus b should be equal to 11. Now, we have two equations with two unknown constants. I can solve it to find the value of the constant. 2a plus b equal 3, and 4a plus b equal 11. Multiply this equation by 2, then the answer is 4a plus 2b equals 6, and the second one is 4a plus b equal 11. Subtract these two equations, 4a minus 4a 0, 2b minus b, 6 minus 11, negative 5. The value of b equal to negative 5. Substitute the value of b here or here to find a. I'll substitute here. 2a minus 5 equal to 3. 2a equal to 8. A equal 8 over 2, 4. Question number 11. Find the value of a and b so that the function f of x defined by this image have no points of discontinuity. First, I need to redefine this absolute value. As you know, absolute value x less than or equal a, it means negative a less than or equal x less than or equal a is constant, any real number, and absolute value x greater than or equal a means a less than or equal x, negative, a less than or equal x less than or equal negative a. Therefore, I'll use this rule to redefine this function. Then x plus 1 less than or equal negative 4 greater than or equal 4. Add negative 1 to all sides of this inequality. 4 minus 1 less than or equal x plus 1 minus 1 less than or equal negative 4 negative minus 1. 4 minus 1, 3. Negative 4, negative 1, negative 5. Then the function will be 2x minus 1, negative 5 less than x less than 3, and x power 2 plus ax plus b when x greater than or equal to 3 less than or equal negative 5. Now, the limit of this function exists when x approach to 3 and when x approach to 5. When x approach to 3 from left, when x less than 3, the function is 2x minus 1. The value of this limit is 2 times 3 minus 1. 6 minus 1, 5. And the limit when x approaches to 3 from right, when x greater than 3, the function is x power 2 plus ax plus b. Substitute every x with 3. The answer is 9 plus 3a plus b. And these two values should be equal. 9 plus 3a plus b equal to 5. This is the first equation. The second equation, I find it from the limit from with when x approaches to 5 or to negative 5. When x approaches to negative 5 from left, the function is x power 2 plus ax plus b. And the answer is, substitute every x with negative 5. Negative 5 squared, 25 minus 5a plus b. And the limit when x approaches negative 5 from right, when x greater than negative 5, the function is 2x minus 1. 2 times negative 5 minus 1, it is negative 11. And 25 minus 5a plus b should be equal to negative 11. Now, I have two functions with two unknown constants. Let me rewrite this function, this equation as 3a plus b equal to 5 minus 9, negative 4. And this function, negative 5a plus b equal to negative 11 minus 25, negative 36. Now, let me solve it here. 3a plus b equal negative 4 and negative 5a plus b equal to negative 36. Subtract by subtraction. Negative b with positive b. 3a plus 5a, 8a equal to 32. 36 minus 4, 36, 32. Then a equals 32 over 8 is 4. Now substitute the value of a here to find the value of b. 3 times 4 plus b equal to negative 4. b equal negative 4, negative 12, b equal negative 60. So a is 4, b is negative 60. See you next lesson.